This statement is true, because the test size is 20%, 0.2, and the total number of samples is 100. Each test set will have 20 samples. 100 asterisk 0.2 equals 20. Consequently, each training set will contain the remaining 80 samples. 100 minus 20 equals 80. This is a direct consequence of how the test_size parameter is defined in ShuffleSplit. Absolutely true. The _random_state acts like a seed for the random number generator. Think of it like setting the starting point for a random number sequence. By fixing this value, the shuffling process becomes deterministic and reproducible. Run the code again with _random_state equals 42 and you will get the exact same splits. This statement is false. _ShuffleSplit does not guarantee distinct splits. What this means is that the same sample might end up in the test set multiple times across different splits. It shuffles the data each time, so there's a chance of overlap. This is a fundamental characteristic of ShuffleSplit's design. It's not designed to create entirely non-overlapping splits. This refers to a method for splitting data into training and testing sets. It's a type of cross-validation, meaning we're splitting the data multiple times to get a more robust evaluation of our model. The stratified part ensures that the proportion of different classes, like Class A and Class B in our quiz, is maintained in each split. The ShuffleSplit part means the data is randomly shuffled before splitting. This tells us the size and composition of the data we're working with. We have a total of 100 samples, 20 of which belong to Class A, and 80 belong to Class B. This class imbalance will be important to keep in mind when evaluating the stratified sampling. This line specifies the parameters for creating the splits using scikit-learn's _ShuffleSplit n_splits equals 5 means we'll create 5 different train test splits. _test_size equals 0.2 means each test set will be 20% of the total data. 20 samples out of 100. Random_state equals 42 sets a seed for the random number generator, ensuring the same splits are generated every time we run the code with these same parameters. This is crucial for reproducibility. 1 of 5 train test splits generated by _ShuffleSplit. Each split will have a training set and a test set. Since this is stratified sampling, the approximate ratio of Class A and Class B will be preserved in each split. Another train test split from _ShuffleSplit. The same proportions of Class A and Class B are intended to be maintained in the training and test sets as in Split 1. The random shuffling ensures that the data is different from Split 1. Yet another one of the 5 train test splits with the same class distribution goal. This split would also have the same approximate proportion of Class A to Class B like other splits. Another independent train test split generated by ShuffleSplit. Again, maintaining the intended proportion of Class A to Class B in both training and test sets. The final train test split, maintaining the class distribution across training and testing sets like other splits. Because the test size is 20%, each training set will contain the remaining 80 samples. This number remains constant across all splits. Similarly, since the test size is 20%, each test set will contain 20 samples. This also remains constant across all splits. This question asks us to analyze the results of using sklearn Model_selection ShuffleSplit for stratified k-fold cross-validation. We need to determine which statements about the splits are true, given a specific dataset and parameters. Let's dive in. This introduces 4 statements, A, B, C, and D, about the characteristics of the splits generated by the ShuffleSplit function. Each statement will be evaluated for its accuracy based on the provided context, dataset size, class distribution, parameters used in ShuffleSplit, and its inherent behavior. It's a multiple-choice question, so we need to consider each statement carefully. This statement claims that the stratified sampling within ShuffleSplit will perfectly divide Class A and B samples in each test set. This might not be completely true due to the randomness inherent in ShuffleSplit. Let's see if that's perfectly precise. This statement addresses the size of the training set for each split. With a test size of 20% and 100 total samples, the training set will always have 80 samples. 100 minus 20 equals 80. This seems straightforward. Let's check the math. This statement highlights the role of the random_state parameter in ShuffleSplit, which controls the randomness of the split generation. By setting this value, in this case, 42, the function will produce the same random splits each time it's run with the same parameters. This is about reproducibility, a crucial aspect of machine learning experiments. This statement discusses the uniqueness of the splits generated. ShuffleSplit does not guarantee that the splits will be entirely different. Overlap between test sets is possible across different splits. It's about understanding the core design of ShuffleSplit. This describes the method used to split the data for cross-validation. Stratified k-fold ensures that each fold maintains the proportion of classes in the original dataset, while ShuffleSplit introduces randomness to avoid bias from the data order. This is crucial for building reliable machine learning models. The dataset contains 100 samples distributed across two classes. 20 samples belong to Class A, and 80 samples belong to Class B. This class imbalance is something to keep in mind when analyzing the results of the cross-validation. These are the parameters for the ShuffleSplit function. n_splits equals 5 specifies that the data will be split into 5 folds, or sets of training and testing data. test_size equals 0.2 means that 20% of the data will be used for testing in each fold, leaving 80% for training. random_state equals 42 sets a random seed, which ensures that the same random splits will be generated every time the code is run with these parameters. This is very important for reproducibility. This illustrates the outcome of the ShuffleSplit process. The dataset is divided into 5 splits. Each split consists of a training set, 80 samples, and a test set, 20 samples. Stratification aims to maintain the class proportion in the original dataset throughout the different splits. However, because of the small number of samples in Class A, perfect stratification might not always be achievable. This is a key point to understand when interpreting the results of the cross-validation.